products and the economics of these. This time I will talk about our security solutions across the board for flash, disk, and tape. What is encryption? I think encryption is a necessary technology in an effort to disguise information from people you don't want to see it. Sensitive information sometimes is required to be encrypted for government regulations. In other cases, you want to keep it secret and private because it's related to financial information, health information, or personnel information, maybe of your employees or of your clients. Encryption can be implemented almost anywhere, in the servers, in the storage, in the switches. Nearly every device can incorporate encryption now. Many of the CPUs have built-in encryption capability. Power, x86, even the mainframe has encryption. And there's different types of encryption. I'll explain data in use, data in flight, and data at rest encryption, different times where you do the encryption. So let's take a look at this. Data in use means let's encrypt it as it is being used. As the information is being used, we will do the encryption. This seems kind of strange to people, but imagine you're in a hospital. The doctor needs to see the information about the medical information of the patient, but they don't need to see the credit card or the financial information, because that's not important to the doctor. And so we can encrypt it because as a doctor or a nurse, you don't need to see the financial information. However, if you're in the billing department and you have to send out the bills to the insurance companies, you might need to see the financial information, but not the medical information. So based on who the user is, you can do the encryption. We have this available through a product called IBM Guardium. And Guardium can do this protection and encrypt it based on the user's access type will determine what gets encrypted. We also have the Enterprise Key Management Foundation, which does server-level encryption for the mainframe. And if you do things in the cloud, IBM Key Protect will protect your data when it's in the cloud. A lot of people are surprised to learn that the cloud does not encrypt the data for you. None of the major cloud providers encrypt. Microsoft Azure, no encryption. Amazon Web Services, no encryption. IBM Cloud, no encryption. You have to encrypt the data yourself before it arrives, because it won't be done when it's there. So IBM Key Protect allows you to encrypt the data prior to its arrival to the cloud. And then finally, for your on-premises, data at rest encryption. And you can store the encryption keys either on a USB thumb drive that attaches to the physical device, or using the SKLM server. And we'll talk about both of those. So you might have heard of symmetric and asymmetric keys, so I'll explain this to you. Most people are familiar with different types of encryption. You might have heard of AES or RSA. Those are the two most common. And the number of bits determines how strong the encryption is. 256-bit encryption for AES would take 10 to the 51 years. That's 1 with 51 zeros to process and break using a supercomputer. RSA 2048 would only take 1 billion years, but still nobody has 1 billion years to do that. And why would you waste 1 billion years on a supercomputer to break that code? So symmetric keys means that we use the same key to lock and unlock the data. So I take the data, I encrypt it with the key, and I get encrypted data, and I can take that data using the same key and decrypt it back. And because that key is used for encryption and decryption both, you have to keep it very secret, because anybody with the key can decrypt the data. But it makes it for very fast, and I'll show you where we use that for various storage devices. Now, the alternative is a public and a private key. This is called an asymmetric key pair. And so we have a D key for decryption and an E key for encryption. And so I use the E key to encrypt the data, and I can give this E key to anybody who wants to send me data. If you're a bank, you can put it on your website. Here's the encryption key. to send us data securely. And then only the person with the decryption key can get the data back. So that's what you keep secret. The decryption key you keep secret, the encryption key you share to everybody in the world. And people like that combination because it separates who can encrypt from who can decrypt. So encryption is happening. It's being regulated. There are a variety of storage devices that are implementing it. Newer devices almost have to have encryption to be even considered for many RFPs. Many RFPs will say must have encryption to be considered. Management of the encryption keys is critical because if you lose the key, you lose access to the data. So you definitely want to make sure that the keys are backed up and protected and made secure. Now, the technology choices should be standardized. In fact, all of the encryption standards have been around for 30 years, and there's no reason to have a proprietary encryption. Because even though the encryption algorithm is standard and well known, if you don't have the decryption key, there's nothing you can do to decrypt the data. Now, a big problem for many was that encryption used to have a penalty for performance. That if you encrypted it, it would slow down your application to the point where people were very selective of what they encrypted. Maybe they only encrypted one column of a database, or only concern there that when they had a breach or when someone stole something or whatever, the unencrypted sections were exposed. Sure that when you do encryption, it does not affect your performance so that you feel comfortable encrypting everything. On my laptop, everything is encrypted all the time, 100%. You want to be able to have a key management that makes sense to you to manage all the keys. All right, you don't want to be like that landlord with 500 keys for 500 apartments trying to figure out how to open all the doors. Right? It needs to be logical, make sense. It should fit into your operations. And ideally, we should set up a system so that the security personnel are separate from the storage administrators, so that no one person can have access to all the data. So two people have to get together to work to make changes. So we created the Security Key Lifecycle Manager, SKLM, is a server that hands out the keys to the flash, to the disk, and to the tape drives whenever a key is necessary. And this simplifies the organization of your keys. Now, SKLM doesn't manage the keys themselves, are managed by the administrator of security, and then the storage administrator merely identifies which products use which keys. So there's a separation of duties there. And we're now seeing these keys being used by databases. We're seeing these keys used by smart meters and Internet of Things and other small devices. We see it in the SAN infrastructure and in all of the flash disk and tape storage devices. Does not affect the performance, is completely transparent to the application. The application does not need to know that encryption is happening. It shouldn't have to. You shouldn't have to change your application. Fits in operationally to your existing infrastructure, and it's fairly low cost. One x86 server, you can run SKLM on a power server or an x86 server on a mainframe. Whatever you already have, you can run SKLM. So let's take a look here. There's three different places I can do encryption. I can do encryption in the operating system, in the software, in the application. But that will use up my CPU cycles, and that could be costly. There were various devices that were available in the SAN switches. They connected to the SAN switches, or they were actually part of the SAN switch that did the encryption for you. And people thought, this would be clever. I don't want to change my operating system or application to do encryption. I don't want to change my existing disk or tape drives. I'll just put a box in the middle. Well, it was a disaster. In fact, it only lasted about 18 months. Why? Because if you encrypt in a box, when it gets to the tape drive, it's not compressible. When you encrypt data first, it's so scrambled that the compression has nothing to work with. So you ended up with 3 times more tape cartridges. Instead of a 3-to-1 compression, you got 1-to-1 compression. And as a result, it became very expensive to encrypt in the switch before it got. Ideally, you want to do the encryption after you do compression. Compress first, and then encrypt. And you can do that in the storage device in the correct order. So let's take a look at some of the different encryption levels. We have column level encryption. Here is where you pick and choose only the columns you want to encrypt. Maybe the social security number is encrypted, but the ID number and the name is left alone. Perfectly valid. Database level encryption, where you encrypt the files, the namespace, the table spaces, and the indexes of a database. You can encrypt those components. File level encryption, you can have for all of your documents, your spreadsheets, your PowerPoints, your Word documents can be encrypted at the file level, and there are file systems that will do this for you. Or you can do volume level encryption, where everything stored on the volume is encrypted on your behalf. Now, the most secure is volume level because you don't have to think, what do I need to encrypt, what do I don't have to encrypt? And that has the advantage that you don't have to worry about someone making a decision, I will encrypt or not encrypt, in the wrong way. So let's take a look at the problem of having too many keys. So I mentioned the apartment manager with 500 apartments. They don't carry 500 keys. If they want to show, they instead put a box on the doorknob, and they have one master key. And so when they want to show apartment 55, they open up the box. They have the key for apartment 55 right there. They open the door, show it, put it back in the box. One master key is all they need to carry, not 500 keys. And that way, each apartment has a unique key. So when they rent it out, they can give them that key. But the rest of the time, the master key is all I need for everything else. All right? And so this is a very simple explanation for how you would use a master key versus a private key. So what we've done is implemented this for data. We have a data key that does that individual apartment, and then a master key that opens all of the boxes for all the data keys. So whether that's a disk or a tape, we have a little box inside that stores the key that a master key can open. So every tape cartridge can have its own key, every disk drive can have its own key, and a master key that opens everything. We encrypt it with an encryption key, and you have to have the decryption key to unlock the box. So now we can have that separation between encryption key and decryption key. But since it's faster to do encryption decryption with a symmetric key, we use that for the actual data key. So let's see how this works. Let's say that I am Green Incorporated and I'm sending a tape cartridge to Blue Company, and I want to send them a tape. But I want to encrypt this tape so that nobody in between can rob my truck and steal my information. So I use the encryption key of Blue Company. They gave it to us, and I encrypt it with the blue key. I also encrypt it with my encryption key, the green key. So I have now my lockbox with a green lock and a blue lock, and you can use either key. I can use the decryption key of my own or the decryption key of blue key to read and write to this tape. But the tape, the data, has its own key unique to that cartridge. And the advantage here is that I can use either green or blue key to open the box, open it, take the key, and use that key for all the data. All right? When it arrives to Blue Company, they have the decryption key. They can open this box, get the red key, and use it for all of the data. It was safe in transit in the truck in between the two buildings. So this is good. And if they needed to add more information, the green could use the key to unlock it, add more information, and lock it back again. So instead of exchanging 500 keys between companies, you just exchange encryption keys. You keep the decryption key secret, but you give the encryption key to the companies that you need to receive tapes from, and they will encrypt it with your encryption key, and you can interpret the data with your decryption key. Public-private keys. So this works out very well with suppliers, with business partners, any companies that have to send you information, you exchange encryption keys. Now, what happens if you're worried that somebody has exposed the key and we need to re-encrypt it with a new key? Well, here's the advantage. No one has the red key. So you can take and change this lockbox from a green key to a blue key, and you're done. You don't have to read and write the entire tape. So the advantage here is that I can do 20 tapes per hour by just changing the lockbox. I don't have to read all the data, re-encrypt it, and write all the data back, because the red key never changes. And that red key is never exposed to the world. It's never accessible outside of the drive. So this solves the problem of having to change the keys if you had to, during a breach or during anything, and you want to protect your tapes. We do the same process with disk. With disk, we have an encryption key in a section of the drive. So what we do is we pass the authentication key and determine, are you authenticated? Is that the decryption key? And if it says yes, we will decrypt it, and we will use that decryption key to process the rest of the data. So one master key, and then each physical drive has its own unique apartment key, the data key unique to each apartment. So let's take a look at how we combine these together. Right? Here's SAN volume controller spectrum virtualized. The other ones work similarly. We are about to write the data, and the first thing we do is we make sure we have 2 copies. 2 copies in the cache, or 2 copies in 2 locations, however you want to organize it. We want to make sure you have 2 copies so you don't lose critical information. No single point of failure. And then once it's in the upper cache, we tell the system, okay, keep going. And then we look at any processes like flash copy or glow mirror that might take some more time. And then when we get to compression, we use the quick assist chip, right? So it's 20 times faster. So we're not going to do it. We'll let the coprocessor do it, because it's 20 times faster to do just compression. And the compressed data now is stored in the lower cache, which is a huge benefit, because your 38 gigabytes of cache now feels like 190 gigabytes. You just multiplied your cache by 5 times more cache, because you're storing compressed data. Now when I write it to the flash or the disk, I do the encryption. So I compress first, and then I encrypt. So doing it in the correct order gives you the benefit of compression and the benefit of encryption. So let's take a look at the master keys and the data keys. For the flash system 900, we have a key pair for your master key and a key for every flash card. So every flash card, you have 12 flash cards. Each one has a unique data key, but one master key for the entire drawer. For the XIV and the DS8000, you have one key for the entire disk array, and then each solid-state drive or spinning drive has a unique key. Spectrum virtualized, one key for the entire system, and one key per storage pool. So you have a gold pool, a silver pool, a bronze pool. Each of those pools will have a unique key, but the one master key unlocks them all. And then for tape cartridges, we have it per tape. We have a master key, and we have a data key. And you can have 1 or 2 master keys, and you have a data key. So this works out well, and we can use this in a variety of different ways. Now, where do we put these keys? That's important. The security administrator either manages the keys on USB thumb drives that are stored in a locked box, or they store it in a key store database that they alone can manage. They generate the keys, and they save them, and they know which ones are which. So when the storage administrator needs to power on a system or needs to reboot the system because they made changes, they need to have access to the decryption key. Because when you boot up the system is when it needs the decryption key to read everything. So in the case of a USB thumb drive, the storage administrator says, please give me the USB thumb drive for this device. Here you go. And then they are able to reboot the system. OK, I'm done. I give you the USB thumb drive back. Now, some people get lazy and just leave it there. All right, so not so good to leave it there in the back of the USB thumb drive. So anybody who breaks into your data center, they will steal the USB thumb drive and the device. They have all of your data. So always take it out and put it back in the lock. You only need it to boot up the system. So once it's running, you don't need the USB thumb drive anymore. Now, the second way of doing this is using the SKLM server. And the SKLM server retrieves the key that the security administrator has organized and sends it to the correct device. So the storage administrator says, this key is for this device, and this key is for this device, and it has all the master keys for all the devices. And it's all done through secure communications, and it's a lot easier to manage. So every time a device boots up, it asks the SKLM server for my key. Please give me the master key. And we already identified which keys belong to that. So let's take a look at how it's implemented across our different products. With tape, with LTO tapes or the TS1100 tapes, we use the SKLM. Every time you mount the tape drive, it asks for the key for that cartridge. It knows the key for that cartridge and is able to then process that cartridge. For XIV, the DS8000, the flash system A9000R, big rack system, when you boot up the system the first time or when you reboot it for microcode updates, it requests the key from SKLM. And SKLM will then provide it the key for that. For the flash system 900, we use a USB thumb drive. And you put the USB thumb drive in there, you boot it up, take it out, put it in the lockbox. With Spectrum Virtualize, which is the SVC, the Storewise, the V9000, or VersaStack, which is our Cisco IBM combination product, you can use either. Some people prefer thumb drives. Other people prefer SKLM servers. Really, the only difference is SKLM servers, you need a server, so maybe a few $1,000s more to run the server versus a thumb drive is only $10, right? Your choice. Doesn't matter either way. If you are writing to the internal devices that are directly cabled, we have the encryption on the SAS controller, so a hardware instructions that do the encryption for us in full speed. No software algorithm is necessary for that. If you are writing to external devices, there is a single instruction in the CPU that does the encryption for us. So again, one instruction instead of a huge algorithm with hundreds of instructions. And you can mix encryption devices with non-encryption devices, and we're smart enough that it's already encrypted. Don't encrypt twice, because that's no benefit. Encryption twice is just extra work that doesn't need to be there. So we're smart enough to say, this is a non-encrypting storage, I will encrypt it. This is already encrypted, I won't. So even though it's in the same pool, we're smart enough not to do the double encryption. Now our strategy is to support both the USB thumb drive and the SKLM across all our products. For the people who prefer thumb drives, great. If the people who prefer SKLM, use that instead. So we're in the process of expanding it everywhere to have both. So SKLM specifically helps deploying encryption. In fact, people who try to do it manually have real problems. Manually managing your keys can be error-prone. You might accidentally delete the key that you needed, and you lose access to the data. So it's a fully automated system. It gives the correct key to the correct device. It's secure and recoverable because now, with SKLM, you can back it up. You can have 2 or 3 SKLM servers. In fact, best practices would be 2 SKLM servers in your primary location and maybe 2 in a disaster location. And then you back it up. almost no performance impact because we only need it on a single tape mount or a single boot up of your disk array is all that it's needed to contact and get the key. So it doesn't affect every record that you read or write. Completely transparent to your applications. Your applications do not need to know that the data is encrypted. They shouldn't care. They should just know that the data is safe and secure. No operational impact. If you have security personnel that are separate from your storage administrators, this is a wonderful system because it keeps the separate roles and responsibilities separate so that no storage administrator has access to the keys and no security administrator has access to the storage devices. So this makes you feel more comfortable that no one person can come in and do everything that is necessary. And it's low cost and efficient. One server that's running on probably something you already have, x86 or Power, and you can run SKLM across the board. It's a Java application, runs on AIX or Linux. So, keep sensitive information secure. Sometimes government regulations require this, sometimes your own corporate policies. Your CEO might say, I want it encrypted, just to be safe. Also, I should mention, what happens if a disk drive fails? You have two choices. I can take the disk drive and send it back to the manufacturer for a replacement, or I can destroy the drive by burning it, smashing it, cutting it in half. If you had sensitive data, do you want to send the data to the manufacturer? Maybe not. In fact, Seagate and Western Digital say that 90% of the drives that were sent back for replacement were readable in the clear, sensitive information. Social security numbers, credit card data, they saw it on the drives, right? But if the drive is broken, you can't erase it before you send it back. It's broken. So if it were encrypted, now you can send it back. You know that you can send it back to the manufacturer and get your replacement. If you didn't encrypt it, now you're paying the full price of destroying the drive and buying another drive at full price. We have huge standards. Pci Dss is the standard for payment card industry that requires encryption. If you do anything with credit card information for any financials, for purchasing, for transfers of data, you need to look at Pci Dss. HIPAA is a standard for healthcare. Privacy information, certain data must be encrypted as a result of that. NERC is related to energy and utilities who are distributing electricity, for example. They have to encrypt certain information related to the infrastructure of that. GLBA and others. Again, compliance, there's probably dozens of regulations that are unique to each industry, and people are now saying, I need encryption. All right? Simplified end-of-life media scenarios. I've seen a lot of people say, okay, my device is now 5 years old. I've depreciated it. It's time to sell it on eBay. Right? But what are you going to do with the information on it? Now, if it was fully encrypted, you just delete the key, and it's now cryptographically erased. You lose the key, you lose all the data, you give it to somebody else. Even though it's got all of that information, they don't have a decryption key, they can't make any information. Or you can hire a company to scan through and write ones and zeros 25 times again and again and again to erase the data. Encryption is a much better way. So everybody has to get rid of their devices eventually. Nothing lasts forever. And if we're encrypted, you feel safe about it. So end-of-life scenarios is a practical reason for encrypting on flash, for disk, as well as for tape. That's all I have for encryption. And